Okay, now that we have introduced the idea of a function and we have a working understanding of what it means and what an equation will be a function, uh, we're now ready to review and apply an idea called function notation. Uh, so the basic idea is it's another way of writing an equation that really emphasizes the idea that we are, in fact, dealing with a function. So in algebra, with an equation, we could write that equation as y equals 4x plus 1. The function notation way of writing it is replace the y with this expression f parentheses x. And that drives home that f is a function of x. F depends on x. We read it typically as f of x, or the longer way of saying it is f is a function of x. Now, in regular old equation language, we say find y when x is -3, right? And that would mean go into the equation, plug in -3 for x, do your arithmetic. So 4 times -3 is -12, plus 1 will be -11, and we get y equals -11. Now that answer, y equals -11, when we have that, is kind of disconnected from the fact that y is -11 because x is equal to -3. One way of kind of reforging that connection is to write your solution down as a point. That kind of reconnects the fact that y is -11 because x was -3. And what function notation does is it takes that idea and it attaches that to the equation form. So it's really a combination, as we're going to see in a moment here, of the equation form and the point form. Because in function notation, instead of saying find y when x is -3, we would just say find f of -3. We would just say find f of -3. Now the overall process is exactly the same. We would write it down as 4 times -3 plus 1, and then we would write it as f of -3 equals -11. Okay. What you do not do here is you do not take this problem and divide by -3 to find out what f is. F is -11. This part is telling us the x value, so that your function notation is kind of a combination of the point notation and the equation notation together. Okay, that's what function notation does. So we don't divide by that because f is -11. This is telling us what the x value is that causes f to be -11. Okay, so be sure to get that idea down with function notation. That's kind of an important idea. Uh, Not to confuse that because that is a common error that some people do make. I see people do that kind of stuff. Divide by -3 there. Okay, but no, that's not there. F is -11. The 3 is just reminding us about the other part of that point. Okay, so that's the idea with function notation. Hopefully that's familiar to you. You've seen it before. Let's take a look at an example here of using function notation. Okay, so here we're given a function. Let's say it's f of x equals 4x plus 7 over x squared minus 2x over x squared minus 2x. Okay. So let's say here that we want to find f of negative 5. Okay, we want to compute f of negative 5. I'm going to give you a little tip here for how to evaluate functions. I'm going to take a look here at some what ideas. Excuse me, I've just completely lost my train of thought there for a second. A little tip here that'll give you a way to evaluate functions if you're having trouble with it. So if we want to evaluate a function, then my advice is to do this. Write the function with blanks. Okay, I'm just going to write the function with blanks. So I'd write this as f of negative 5 of f of blank. And everywhere I see the variable, I'm going to write down a blank. 4 blank plus 7 over blank squared minus 2 times blank. And then simply fill in the blanks. I'm actually going to rewrite it, but in practice, you just fill in the blanks. Right? And that keeps everything straight. Because a common mistake that people will make is they'll neglect to replace every variable part with that numerical value, or, as we're going to see in a moment, with a variable expression. So I'm just going to rewrite the whole thing here for illustration purposes, filling in every blank with negative 5. And then we just follow our normal order of operations to simplify stuff, whether it ends up being a numerical value or whether it ends up being something else. So here I would work out on top. 4 times negative 5 would be negative 20. Negative 20 plus 7 will be negative 13. Okay. On the bottom here, I have negative 5 squared, which will become positive 25. Minus 2 times minus 5 will be plus 10. So we're going to have 25 plus 10 will be 35. And so this just becomes negative 13 over 35. And that's it. That's our answer there. Let's consider a second one here. Let's say we want to make f of 2. So once again, I'm just going to write down, excuse me, I have a crazy dog barking. Okay, so I had a crazy dog. It's gone now. So back to where we were at. So we're just going to write down the function with blanks. 4 blank plus 7 over blank squared minus 2 times blank. Right? And then we're just going to fill in the blanks with, in this case, 2. And I'll write it in blue so it kind of stands out a little bit. And then we just begin working everything out. So on the top, I'd have 4 times 2 is 8, plus 7 is 15. On the bottom, I'd have 2 squared is 4, minus 2 times 2 is 4, 4 minus 4 is 0. So I have 15 divided by 0, but I can't do that. That's undefined. So here we've ran into a value where this function that we were given, f of x equals 4x plus 7 over x squared minus 2x, it's not defined when x is equal to 2. And that's okay, because remember our function, that's why our function was saying the phrase at most 1, meaning 1 or none. So in this case, we saw f of negative 5 had just the 1 value, f of negative 5 was negative 13/35. Here, f of 2 is undefined. It doesn't have a value. Okay, so both of those fit the at most. Now we can also, instead of being given a number, as we were given in these first two examples with a function, we could also be given a value or an expression like, for example, x plus 6. So instead of being given a numerical value, we'd be given an algebraic expression. We still want to evaluate the function, the algebraic function, at that expression. The setup doesn't change. Whether it's a number or a variable, we're going to write everything down with blanks. And then we're just going to fill in those blanks with, in this case, x plus 6, that quantity. And now we just have to go through and do the algebraic work of simplifying this stuff. So instead of having some numerical answer, here we're very likely going to have some algebraic expression. So on top here, I can multiply through by 4 and get 4x plus 24 plus 7. And then I'm just going to keep working with that numerator for the moment so that I get 4x plus 31. 4x plus 31. And now I'm going to go turn to my denominator. And I have x plus 6 squared. Remember, when you square something, that means you're multiplying it times itself. That's not just x squared plus 36. We have to remember the middle piece. So we want to kind of go off the side and write that out, or just recognize that. And then we multiply it out. X times x will be x squared. In the middle, we're going to have x times 6 will be a 6x. And then we're going to have the other middle, 6 times x, with another 6x, so we're going to have a 12x. And then 6 times 6 is 36. And then we have the second part here, minus 2 times x plus 6. So minus 2x and minus 12. And I'm just going to, in my case, slide that back just a little bit. Okay. And then we just keep going and combine any like terms we have. So I have an x squared. I have a 12x and a 2x. We make that minus 10x. And 36 minus 12 makes that plus 24. Now I could keep going with this and, do some other stuff with it. I could factor this denominator, but that's really not going to make much of a difference because it's not going to cancel. That top doesn't break down at all. Right? There's no common factor. And certainly isn't going to cancel with anything here because I have a 1 in front of the x squared. So I have a 4 in front of the x up there. So really good to go there. We can just leave it like that. And so it turns out that f of x plus 6 is equal to this expression here. And of course, that expression doesn't simplify anymore. And so there we've evaluated our function.